represent.
I'm trying I'm trying log of n because हम बाइनरी सर्च कर रहे हैं. ठीक है. So I'm trying to see if there is a way for me to eliminate a certain part of the array, because I'm trying to do something around log of n. Because हम बाइनरी सर्च कर रहे हैं. ठीक है. So I'm trying to see if there is a way for me to eliminate a certain part of the array. So let's take this graph, the generic one. If I'm standing here, okay, left side mein if I move, there will be no peak element. I have to move right to look for a peak, right? Agree? Okay. Now, let's say I'm standing here. In this case, if I move this side, will I find a peak element? Which is right side, right? Because yahan se, if you move this side, these are the next array elements that you are seeing, right? Which is right of the array. If I move right, I will not find a peak element. Whereas if at this point I move left, which is I'm looking for elements smaller than I'm looking for elements before this index, then there is a possibility for me to find a peak element, right? Graph में हम देख रहे हैं, this can be a peak. Agree? Okay. I'm trying log of n because I'm binary. So I'm trying log of n because I'm binary. Now we don't have time. Know that on a certain section if I'm standing, then moving a peak element, and in a graph, if I'm standing at a certain section, then moving left will give me a peak element. Correct? विहार, yes, you are saying कि आप यहाँ से राइट जाओ एंड देन आप ऐसे जाते जाओ, फिर यहाँ पे आपको पीक मिल जाएगा. Yes. The question says that we want to return any of the peak elements. So again, if I move this side, right? If I'm my right eye and then I'm again moving this side, that is basically this part, right? ये वाला part. I'm just trying to generalize it.
Okay, so we are just considering like one step, right? We are like
Yes.
not looking
Either
ahead.
so if you see the lines, right? If you follow, either your line is this or it is this. So I'm saying that any line which is like this, in this case, you will find a peak element only on the right side. यहाँ पे again this line is similar to this, right? Here also you'll feel only if you move right. Here also you'll find a peak element only if you move right.
Okay, yeah. So it's just one step. Makes sense.
Yes. Similarly, the other kind of lines is these three. On all these three, if you move left, then only you'll find a peak element. Kuldeep, yes, you can find, you just have to return any of the peak elements, not the first, not the last, or middle peak, ऐसा कुछ भी नहीं. The question says that I want any peak element. If you have multiple, return the index to any of the peaks. Okay. Now, let's try to see what is the differentiating factor for these 2 points. Why this point gives, you want to come up with a formula, right? Here, visually, I'm able to see that yes, यहाँ पे right move करके I'll find a peak, यहाँ पे left move करके I can find a peak. But now I'm trying to code it up, I'm trying to find a formula for this. What is it that is differentiating these 2 points? Everyone is clear till now? Any questions, anything? Okay. So now, when I'm standing here, right, and I'm standing at this point, what is the property if you see? For this point, if this is ith index, this is a property, right? For this point, I minus 1th value is even lesser than this value, and this value is even lesser than whatever you have at I plus 1. I plus 1, I go I plus 1. मुझे अभी समझ नहीं आया आपने क्या लिखा है. Okay. And what about this index? If again this is ith index, what is the property here? Your nums at I minus 1 is greater than nums at I, which is again greater than nums at I plus 1. Right? If this is the ith index, whatever you had previously was greater than this value. And the next value is even lesser than whatever you had at I. So you're less than, like greater than the symbol. Make sense? Are these two formulas correct? Please verify. This is a differentiating factor, right, for these two. So can I say that, hey, if in this graph, what are the peak elements? What are the points where we have a peak? These three, right? And if you see, the formula for these 3 points is this, right? Sorry. Agree? If this is ith index, then I minus 1, whatever you had previous to I is less than this value. And again, whatever you have after I, which is I plus 1, is again lesser than this. Okay. So ये formula तो हमें ऐसे भी पता था, right? But I just wanted to show it in the graph. Now let's come back to these two formulas. So are you able to see that if the left value is less than the current index that you're looking at, then you can say that, hey, if you go to the left side, you will anyways not find a peak element. This condition I'm saying. If this condition is true, ideally for this to be peak, this should have been greater. This should also have been greater than symbol. But if this is the condition which is satisfied and this condition is not satisfied, which is I and I plus 1, I is not greater than I plus 1, then can I say that, hey, moving left will not give you a peak, you have to move right? Actually, it's this condition, okay? This condition. This should have been greater than symbol, ideally. Then we could have said that this is peak. But because this is not greater than symbol, and this is the condition which is true, I can say that, hey, if you find a peak element, you will find it on the right side. You can just ignore the entire left. इसके बाद अगर इतना बड़ा भी array elements होते, ignore them because there's no way you will find peak element. Similarly, if you see here for these lines, ideally this condition should have been less than, right? If this was less than, I could have said that, hey, this is a peak, but this is not less than. So if you encounter this condition where I minus 1 is greater than I, then I can say that, hey, moving left will only give you a peak. Right में आप जाओगे तो you will not find a peak element. Yes, just as I and I minus 1. If I is less than I minus 1, नहीं क्या लिखा है? I or I minus, अच्छा I पहले हाँ, okay, correct. If your I minus 1 is greater, then you have to ignore the entire right side. Are you guys able to follow? Any questions? Writing a code for this is another thing that we'll discuss, but is the intuition understandable, clear कि binary search कैसे लग रहा है यहाँ पे? Last logic क्या था? Last logic? What was the
this one, like जब num I minus 1 is less than num I and then this one. ये जो last में पूरा बताया ना, वो चीज़ थोड़ा सा confusing था बस.
ये वाला part?
हाँ.
और ये भी?
हाँ थोड़ा सा. वो I guess थोड़ा सा miss out हुआ मुझसे.
No worries. So what I was saying is when I'm standing at this I index, what is the property? I minus 1 is less than I and I is even lesser than I plus 1, right? This is the property.
Right.
And when I'm standing here, I minus 1 is greater than I and I is even greater than I plus 1. Right? वो लिखा है मैंने. Now I'm saying for this to be a peak element, ideally ये वाला part greater होना चाहिए था, right? Symbol, greater symbol होना चाहिए. अगर ये greater होता तो you would have said, right, कि this is peak.
Yes.
So this condition is true. This is less. I is less than I plus 1. If this condition is true, then I can say, right, that if going to the left side will not give you a peak element. You have to move right.
Okay.
So I'm saying if this condition is true, eliminate the left half, go to the right half. Similarly here, ideally this condition should have been less than I minus 1 should have been less than I. तब आप बोल सकते थे कि ये peak element है. But because this is greater, can I say that if this condition is true, you can eliminate the entire right half and move to the left half?
Right.
So for binary search, we need three conditions, right? One is, what is the condition to say that this is your answer? Whatever index mid index you are looking at, this is your answer. That is one condition. Then there are two more conditions you need to eliminate the left half or the right half. So what I'm saying is, this is your condition to check whether the index that you're standing at, the mid position, whether if you're standing at mid position and this condition is satisfied, that means mid is your answer. If mid is not satisfying this condition, then if this condition is true, so eliminate the left half and move to right, which is low equal to mid plus 1. Else, if this condition is satisfied, then move to the right half, left half. Make sense, people?
Yeah.
Okay. Most possible cases, mid and peak at same position. Mid behind peak. Correct. Yes. Mid and peak at same position is this conditions. This. Mid is behind peak is this condition, and mid is after peak is this. Thanks. Just such. Okay. Now coming to how do you code this up? There are a few edge cases to like writing this code. Can I directly so is everyone clear? Can I go ahead with the pseudo code? Any questions? सिन्हा जी आपने क्वेश्चन को किया था क्या बाइनरी सर्च से या आप वो लीनियर वाला ही बोल रहे थे कि हमने सर रखा है? Is he here?
तो किया था.
Sorry?
दोनों मेथड यूज किया था, लीनियर सर्च एंड बाइनरी सर्च.
Okay, then cool. Yes, Rajat, that's correct. So I'll go ahead with pseudocode. So you start with low equal to 0, high equal to n minus 1, and some mid initially some negative index. Condition, again, search space, you have a valid search space till low is less than equal to high, right? First of all, you calculate mid, which is low plus high by 2. Then, if array at mid minus 1 is less than array at mid, which in turn is greater than array at mid plus 1, you will say that, hey, this is my peak element and return mid, right? This is the index I can return. Otherwise, if array of mid, condition mid is less than mid plus 1. Low equal to mid plus 1, else high equal to mid minus 1. Right? Simple? Make sense? But this will fail. Kind of fancy code. What if there's only one element? Shreya ka question hai. Okay, so let's say uske liye I just write a condition here that if n is equal to 1, return num at 0. Would this work? No, Hariom, I'm not saying ki, see, when I'm standing here and I'm saying that, hey, if this condition is satisfied, eliminate the entire right half. That doesn't really mean, right, कि right half में peak नहीं, right में हमें यहाँ पे peak मिल रहा है. But because the question says that, hey, I want any of the peak elements, so I'm saying that if you're standing here and this condition is satisfied, instead of looking for the peak element which is in the right side, look for one which is on the left side, because I'm trying to apply binary search. Does it make sense, Hariom? So when we say that, hey, eliminate the right part for this question, it doesn't mean that you will not find the answer in the right part, unlike the typical binary search that we have done. It simply means that यहाँ से right जाके आप करोगे तो आपको वापस से linear कुछ करना पड़ेगा. So instead of that, try to find a peak on the left side. Because if you consider these two cases, then you will be able to apply binary search. Did it make sense, Hariom? What if there's no peak element in the left part? In that case, it will lose on the only peak. Try to draw a graph and see. I get it. You're saying कि अगर हम यहाँ पे हैं, यहाँ पे आप I कैसे हो गए, Hariom? How will you be standing here? Graph में if you're standing somewhere on this line, there would be a starting point, right? एक peak रहा होगा ना, वहाँ से तो नीचे आए होगे. What can I say? Like consider it climbing a slope or something, or climbing a mountain. If you're going down a mountain, this is like going down a mountain, right? If you're able to go down the mountain, then there would be a top of the mountain, right? वहाँ से आपने start किया होगा, that is why you're able to go down the mountain. समझ आ रहा है? Similarly, you can say that, hey, Garima, what if I had, let's say, considered कि, you know, I'm standing here, and I would say that, hey, consider your peak on the, this can be your peak element, right? This is what we said, that if you're standing here, right side will have peak. So I'll say that, hey, moving this side will give you a peak, and moving this side won't give you a peak. So you'll say that, hey, but here I have a peak, this is left side. But again, same thing. The fact that you're standing here, you're climbing up the mountain, that means आगे जाके आपको peak मिलेगा ही मिलेगा. आप ऊपर जा रहे हो तो there will be a top of the mountain, right? So I would like to point this out, guys, and this is a very good question from Hariom. This can be probed in an interview. They might ask you that, hey, you have a peak element on the right side. Why are you doing this? Why are you saying that you will not have a peak element on the right side? So you have to clarify that in this case, when we are applying binary search, it is not a typical binary search where we say that, so in typical binary search, what do? We eliminate a certain half of the array, and we say that, hey, you will never find the answer in this side. That is why I am eliminating this part. That same logic, you cannot say that statement for this question. You cannot say that, hey, I'm eliminating the left part because I'm eliminating the right part because there will never be an answer on the right side. You cannot say this. Yes, correct. Understood? You either start or down, correct. Any other questions? And also, what is the problem in this code? एक तो श्रेया ने बताया, which I wrote here, a special case. Strictly increasing or decrementing array might be the edge case. Yeah, मतलब ऐसा कुछ हुआ तो उसमें क्या प्रॉब्लम होगा? I'm just trying to understand. No, that is not the. What about the elements that are at the borders? How we are handling them? Correct.
So if the elements at the start of the end are the peak elements, then it's not necessary to implement the binary search.
Correct. That is one thing. What else? So now you are correct. कि binary search implementing मत करो ना अगर first या last element है तो just like this I have a case. Write another case checking if first element is the peak element. Return that. Don't do any binary search. Same with last element. Cool. But again, this would fail. This part would fail. Where would it fail? इसीलिए तो बाउंड्री पीक नहीं बाउंड्री पीक के लिए आप एक कंडीशन डाल दो दैट वुड हेल्प लुक एट दिस कोड
लाइक हमारी स्टार्टिंग ही पीक से हुई तो
हाँ तो अगर आपकी स्टार्टिंग पीक से हुई 0 है लेट्स से राइट 0 से n minus 1 is the range I'm considering your mid might come and stand at 0 and then if that is peak you will get an answer okay out of bound yes that is what I was looking for so if you see if I'm standing at mid which is 0 right I'm trying to fetch an array element which is 0 minus 1 array element at minus 1 can I do this would this not give you out of bound error similarly if I'm standing at n minus 1 and I check for n minus 1 plus 1 element which is nth element again that is out of bound so if you run this code you will get out of bound error. So how do we handle this? We handle this by starting your low and high, like one of the standard ways to handle it. Otherwise, you can write like यहाँ पे you can write multiple if else cases. यहाँ पे before doing this comparison, right? यहाँ compare करने से पहले you can check mid minus 1 range में है कि नहीं अगर है then check this else do something. You can make your code complicated. Out of bounds ऐसे होगा कि your mid and low and high are at 0 and n minus 1, right? What if your mid is standing at 0? If mid is equal to 0, what will this value be? Minus 1, right? Can you access array minus 1 element? That is out of bound, right? Same with if you're standing at last element. If mid is n minus 1, what would this be? Array of n. Again, that is out of bound. So one of the standard ways to deal with this is make this 1, make this n minus 2. And so basically when I say 1 and n minus 2, what does it mean? If this is your array, I'm saying search for a peak element in this part. And it is possible, right? And you might not find a peak element here. It is possible to carry a peak element first or last element. And this is not what would give you a peak element. So before running your binary search from 1 to n minus 2, just check for the border elements. If they themselves are peak, return the answer. Don't do binary search. If they are not peak, then run a binary search from 1 to last second element. So that you don't run out of bound case. Make sense? This is just standard way. आप इस code को भी modify कर सकते हो to deal with this out of bound, just that your code might become non-readable or a bit difficult to read. Understood? Any other questions? Okay, I've started updating the resources in a bit different location. So let me just see if I can share my screen. Just a second, guys. I just want to show this so if people want to start contributing, they can do that. Visible on your screen?
Yeah, it's visible.
So previously all the sessions MD files were here, right? So till 30th session, I've updated till this point. 34th session, yesterday's session onwards, you will see the resources in this folder, okay? Same folder structure ka naam same hai. Within this, you have a session MD file which will have the resources. And here you can create, like if you want to contribute to a C++ solution, you can create a folder and push your solution in that folder, okay? And raise here. Make sense? Solution, you can create the resources. And here you can create, like if you want to contribute to a C++ solution, you can create a folder and push your solution in that folder, okay? And raise here. Make sense? And PR raise करते time, please keep your one second. PR raise करते time, please keep your problem name followed by your name dot the extension. Username language.exe. Language नहीं username नहीं मुझे actual name चाहिए. मतलब username में लोग कुछ भी ऐसे random दे सकते हैं.
Yeah, I meant user space name.
Yeah. अरे मतलब अब आपका नाम सिनज तो नहीं है, right? So you cannot be pushing like so question problem name followed by सिनज तो नहीं चलेगा. ठीक है, रैंडम यूजर नेम्स कुछ मत डालना, बाकी कुछ भी चलेगा. सो फॉर एग्जांपल जैसे ये था ना सर्च एंड सॉर्टेड रोटेटेड एरे, तो इट कैन बी समथिंग लाइक फॉलोड बाय गरिमा. ठीक है, दिस कैन बी द फॉर्मेट.
And will it not contain like which language is this question solved?
आप लैंग्वेज तो आपका .cpp .java .py ऐसे रहेगा ना,
Okay.
तो वो अलग से लैंग्वेज आपको नहीं डालने की जरूरत. ठीक है, विल डिस्कनेक्ट देन. एनी अदर क्वेश्चंस? मैंने कल के रिसोर्सेज ऐड कर दिए हैं, मैं पिंग करना भूल गई थी. आई विल पिंग आफ्टर द सेशन. Cool. Thank you. See you guys tomorrow.
by dx.